So we are discussing binomial distribution and its moments. We know that if x follows a binomial distribution, we are going to write that in this way, and these two are called the parameters of binomial distribution. As it is a discrete distribution, we know that this is the PMF of binomial distribution, where x is from 0 to 1 to n. So I think we have already derived the first two moments called mean and variance of binomial distribution. Now we are going to derive the third and fourth moments, which are called mu3 dash and mu4 dash. So mu r dash is nothing but expectation of x bar r. Now mu3 dash will be expectation of x cube. So as this is a discrete variable, you know that we are going to replace that with sigma x cube into p of x. So I said you x you will take as it is. X square we have written with x into x minus 1 plus x. Similarly, x cube we are going to replace that x cube with sum of three terms called x into x minus 1 into x minus 2. I think this was already given to you, the formulas for this. We can write x cube as this. If you simplify all these, you are going to get x cube. So directly we are not going to consider this. This x cube is going to be replaced by the equivalent expression like this. Now this will be, you separate for each of these terms, x into x minus 1 into x minus 2 into p of x plus 3 into sigma x into x minus 1 into p of x plus sigma x into p of x. So I think if you observe, if you look back into your mu2 dash, this is nothing but the first term in mu2 dash. This is nothing but mu1 dash. This is nothing but mu1 dash. And second term, no need to calculate. This is nothing but mu2 dash, first term in mu2 dash. So only you need to evaluate the first term. So mu3 dash is nothing but sigma x into x minus 1 into x minus 2 into p of x, and we got the first term in mu2 dash is n into n minus 1 into p square plus np. These we have already derived while doing mu2 dash and mu3 dash. So you need to find out only this term. So consider this term. So what is p of x for binomial distribution? X into x minus 2 into ncx p power x q power n minus x. So again the same simplification what I said. First you expand this using n factorial by r factorial into n minus r factorial. After that again you need to expand n factorial in the numerator, x factorial in the denominator. Then in the for the power p, as we are doing mu3 dash, add and subtract 3 here and there. I think the same process which we for mu2 dash and mu1 dash. So here we have considered this term. What I said, how to start the simplification for this term. Write this x as x is the variable here, x minus 2, and cx you are going to replace with n factorial, n minus x factorial into x factorial. Write these two as it is. Now in the next step you expand these two, means sigma x into x minus 1 into x minus 2, n factorial is till you need to write till 2. As we have x into x minus 1 to x minus 2, you also replace this n up to n minus 2 into n minus 3 factorial. The denominator one also you write this as it is, n minus x factorial. This x factorial you are going to expand x into x minus 1 into x minus 2 into x minus 3 factorial. These three terms are going to cancel. And here you have what I said, you add and subtract 3 in the powers of both the terms. So here as x is a variable, you can take out these three terms out of the sigma n into n minus 1 into n minus 2 sigma n minus 3 factorial by x minus 3 factorial. Here also you add and subtract 3 n minus 3 minus x minus 3 factorial. So this is nothing but minus 3 minus of minus plus 3. So if I write n minus 3 x minus 3, I will get n minus x only. So I am writing this in terms of n minus 3 and x minus 3. I will write this as p power x minus 3 into p cube. This one also I want to write this as n minus x n minus 3 minus x minus 3. So here again you can take out p cube, as this is independent of x, we can take out that out of summation. You got, we can write this as n minus 3 x minus 3 p power x minus 3 q power n minus 3. So you got n into n minus 1 into n minus 2 into p cube. Okay, this is nothing but what is the general expansion. I said to remember, for each distribution we are going to follow an expansion under binomial expansion. The expansion for binomial distribution is q plus p. In place of n we have n minus 3. So this will be q plus p whole power n minus 3. As q plus p is equal to 1, you will get that as n into n minus 1 into n minus 2 into p cube 1 power n minus 3. 1 power anything is same. So you got the first term in this mu 3 dash. We are doing mu 3 dash. The first term we have evaluated, which is nothing but n into n minus 1 into n minus 2 into p cube. The second and third terms are already done. N into n minus 1 into p square plus np. So I think this is mu 3 dash. Still we need the third central moment called mu 3. What is the formula for mu 3? Mu 3 dash minus 3 mu 2 dash mu 1 dash plus 2 mu 1 dash cube. This is the formula for mu 3 dash. So if you replace in this recurrence relation, you are going to get mu 3. So let us do that. What is mu 3 dash? N into n minus 1 into n minus 2 into p cube minus still we have plus this one 3n into n minus 1 into p square plus np. This is nothing but mu 3 minus 3. I want to use this. We have the expression for mu 2. What is mu 2 dash? Mu 2 dash is n into n minus 1 into p square plus np. Mu 1 dash is np. So n into n minus 1 into p square plus np into what is mu 1 dash into np plus 2np whole cube. I think from all these three terms we have 1, 2, 3, 4, 5 terms. From all these we can take np as the common term. If you take out np common, here you will be with n into n minus 1 into n minus 2 into if you take out np common, you won't get n here. N minus 1 into n minus 2 into p square. If you take out np common here, you will get n 3 into n minus 1 into p. So here you will get 1 minus 3 into, if you take out this np common, you will get n into n minus 1 into p square plus np plus 2np n square p square, as you are taking 1 n as common. So you multiply these inner terms. I think how much you will get? You can multiply these two binomials. You will get n square minus 3n. Just do it. You can do this multiplication. I am writing those directly. I want to rewrite this 3. I can write n into p is np. np minus p plus 1. Let us multiply these also. Then you will get 3 into n square into p square, n square p square, n into 1 n minus np square plus np plus 2n square p square. Okay, you do it from here. Anyway, I will continue, but better you practice it, then only you can get the simplified expression. So we took np common. The previous we have n square. I think if you multiply these two, you will get n square p square, 3n square b, 2np. Similarly, 3np minus 3p plus 1. 3 is to be multiplied for all these terms. This I am writing the same in the next step. N square p square minus 3np square plus 2p square plus 3np minus 3p plus 1 minus 3n square p square plus 3np square minus 3np plus 2n square p square. I think we can see some cancellation within this. We have 2np square, 2n plus np square, n square p square. I think these two are like terms. You will get 3n square p square. This is going to cancel with this. These three terms are cancelled. Now, and what else you can cancel here? Minus 3np square plus 3np square. Okay, and you have minus 3np plus 3np. So simply you got 2p square minus 3p plus 1. Now I think you can split the middle term, or we can write this as by factorization. For 2, I think we can write in this way. We have 2 here. For 2, factors are 2 into 1. We can write 2p square minus 2p minus 1. So np into, if you take out 2p common from this, p minus 1 minus 1 into p minus, regular factorization, np into 2p minus 1 into p minus 1. So let us see. Is again further simplification for this. Is p plus q is equal to 1? Okay. Then what will be p minus 1 will be minus q. If you take this minus 1 here, this will be minus q. And now I want to write 2p minus 1 we can replace with p plus q. So minus p minus q into, this is nothing but minus q. So this is np into 2p minus p minus q. You can bring this minus here into q. As mu3 can be negative, but let us absorb this minus into this term, so that you will get npq into q minus p. So this is the expression for mu3. So mu4, I will do only half of it. Try to do the remaining part. What is the formula for e power x power 4 is? So this will be sigma x power 4 into p of x. What I said, don't take this as it is, as we have formulas for x power 4. What is the formula for x power 4? You will get till x minus 3 plus 6x into x minus 1. You should by heart this, plus 7x into x minus 1 plus x into p of x. So if you multiply with this, how much you will get? Sigma x into x minus 1 into x minus 2 into x minus 3 into p of x plus 6 sigma x into x minus 1 into x minus 2 into p of x plus 7x into x minus 1 into p of x plus sigma x p of x. So if you observe likewise mu3 dash, this is only to be evaluated. This you can consider from mu2 dash. This from mu2 dash. This is from mu3 dash we can consider, which is already evaluated. Mu2 dash from mu1 dash. So in the similar way you find out the expression for this. I'll write the final expression for mu4 dash, which we will get as n into n minus 1 into n minus 2 into n minus 3 into pq plus 6 into n minus 1 into n minus 2 into p square plus 7 into n minus 1 into p square plus np. You can leave and you can write mu4 directly. No need to simplify this. Generally in the examination you will be asked with mean and variance only. If not, up to 3 terms he is not going to ask. Even though he asks, you can write these up to mu3 you can derive. From mu4 you can write directly. Just I want to tell you how to remember these long expressions of the first 4 moments. What is the PMF of a binomial distribution? This is the PMF of binomial distribution. You should remember the general expansion which we are going to use. What is the general expansion here? Q plus P. Okay. Now after this I think we have mean. We are going to write this as sigma px. So you will get np here. Okay. So if it is mu2 dash, this is nothing but sigma x square p of x, which we are writing that as x into x minus 1 into x minus 1 plus x into p of x. So to remember, how to remember these when these long expressions means, this is mu1 dash easily only, but if you look at this expression, you have x into x minus 1 into So you'll get in the final expression n into n minus 1 into p plus np. Okay, for each x, just to remember, it's not a scientific way, n x in the final answer after simplifying, x you are going to replace with n, p of x you are going to replace with p. Similarly, mu 3 dash, what is the formula for mu 3 dash? Sigma x cube into p of x. So better you remember the formula for x cube, x into x minus 1 into x minus 2, 3 into x minus 1 plus x into p of x. So by the same logic, how do you get the mu 3 dash expression? N into n minus 1 into n minus 2 into p of x means p. Not here p square, here p cube, not simply p. As we are doing second movement, you will get p square, here p cube plus 3 into n, this as we have 3 here, 3 into n minus 1 into p square plus np. I think the powers are reducing by 1. Similarly, mu 4 dash is sigma x power 4, which we write as sigma x into x minus 1 into x minus 2. You should remember these 6 into x minus 1 into x minus 2 plus 7x into x minus 1 plus x. So for all these, how much you will get? N into n minus 1 into n minus 2 into n minus 3, as we are doing the fourth order moment, p power 4 plus 6, as you have 6 into n minus 1 into n minus 2 into p cube plus 7 into n minus 1 into p square plus np. Okay, thank you.